All yours. Thanks, Ed. Thank you all for being here today. Chris Catterton, Director of Solution Engineering at OneTech. We were formed in 2018 through a joint venture between two organizations, one called Plasma, familiar with this group, and a company out of Tokyo, Japan called Sistina. Plasma, Sistina, longtime partners, came together and formed this joint venture really through, they were partnered on a industrial IoT deployments and realized just the sheer amount of data that is generated in some of these deployments. We're talking about hundreds of assets. Some of the sensor data points were coming through every 100 milliseconds. So we knew that shipping all of this data to the cloud really just was not an option. So we formed OneTech to really solve that massive amount of data being generated through these IoT projects. And today I'll kind of walk you through the various products that we've created. Online, we have Brad Webb. Brad, if you were there, do you mind just giving a quick intro as well?
Yeah, good morning, everybody. Brad Webb, based out of Houston, run the sales organization over here at OneTech. Joined, I guess it was in July or August of last year. Prior to that, I was 20 years over at AT&T and the IoT organization. So look forward to the meeting today. Thanks.
Well, with that, let's jump in here. So I'll give a quick intro of who we are, what we do, and really dive into the state of the industry, right? So we're all here for IoT. I'm going to look at IoT and really AI as well. With that, kind of dive into some of the technology, how it works, and big thing, training AI models directly on the MCUs. Very, very unique for the space. We'll go into some example deployments and look at a quick technology demo video. As we go through this, people in the room, feel free to jump in, interrupt me, ask questions, and we'll have a Q&A at the end as well. So OneTech, we really work with device and equipment OEMs and owners to provide insight to how those devices and assets are performing out in the field. We do so by embedding a bit of code directly on that asset itself. Early days, we're living on, think, microprocessor-based devices, and now today, really moved that all the way down to the microcontroller environment. So it's really, looking for signs of failure, general anomalies that are happening with these assets. Flagship product is a product called Microai. It's the code that's living on those MCUs or embedded environment. But we also have, the solutioning around just the AI for asset owners to manage those devices, push code updates, trigger workflows, etc. So focusing on the Industry 4.0 powered by AI for these solutions. So by collecting and training and processing that data at the endpoint, certainly provides a heightened level of privacy and security of that data, and also comes with a lot of cost savings. So let's dive into some of those benefits. And first, let's start with just the challenges of a cloud-driven AI approach. Right. So today, to date, a lot of deployments for AI have been solely relying on the cloud to do so. Right. So you're taking a lot of historical data up into a cloud, processing that data, forming the model, and potentially moving that model down to an edge or an endpoint, but that model's being generated up into a cloud. So in doing so, you have to ship all that data to a cloud to begin with. And again, some of these IoT deployments, lots of raw data being generated. It's a lot of data going across a protocol, whether it's cellular, could be satellite, what have you. And it's a lot of connectivity costs in moving all of that raw data. And of course, the cloud cost. Storage is rather inexpensive, but once you start crunching numbers, it can add up on you. Some of the enterprise clients that we work with, we're talking about hundreds of facilities across the globe, tens of thousands of assets that are generating data. So lots of data that would need to be sent up into the cloud. Latency, as Chris, you and I were speaking about earlier, right?
The big issue.
Making the round trip of all that data from the endpoint up into a cloud, processing and shipping that back. Sometimes, even 500, 800 milliseconds does cause some disruptions. accuracy of the data. And I'll dive into this in a bit in more detail, but by taking this cloud-driven AI approach, and the challenge with that is you're taking a batch of historical data and training that model and pushing that model down. You're hoping that that data that you're taking to a cloud to form the model is the correct set to form the model itself. And again, I'll dive into that here momentarily. Security, right? You're moving that data off the local environment. More hops of that data or various vulnerabilities that could potentially arise due to moving information from point to point. And privacy really goes hand in hand with security. So those are some of the challenges that we see with the cloud-driven AI approach. With that, look at MCUs. So according to this study, we're looking at close to 11% growth rate of MCUs between now and 2027. So there's going to be just more and more data generated by billions of devices that are out into the field. And that cost of what you do with the data is certainly going to rise if you take that cloud-driven AI approach or cloud processing approach. So let's look at the architecture of a cloud AI implementation. So actually starting on the far right-hand side of the screen, again, you would take the data that's generated from your various assets or equipment devices out into the field, up into a cloud. That's where the cloud would train the model, form the model, do all of the processing of that data. So basically all of your raw data from your embedded environments, right? All those devices, sensors, what have you, go through potentially an edge or directly to a cloud to be processed, right? So all of your raw data is moving from the endpoint all the way up into a cloud. Now, in the last few years, we've seen a lot of edge computing deployments where the data doesn't need to make that full round trip. With this, the AI model would still be formed into a cloud, but move to that edge for processing of the information in the edge location. So instead of raw data making a full trip up to a cloud, it's simply just going to the edge and back to that endpoint. Where we see the market going and where we really play here at OneTech is in the embedded space. So instead of data needing to leave that endpoint, all of the model creation and processing of that data is there in that embedded environment. And so think, let's have a critical asset for oil and gas sites. It could be a pump jack in Midland, Texas. I don't need to see all of the raw data if that machine is performing normally. It's actually just noise, right? So I would prefer to just be alerted when there is a sign of failure or a general anomaly occurring with that asset. So a lot of the IoT devices deployed for at least these remote assets are typically battery operated, and telco people here know that the connection to the network is one of the heaviest impacts to battery draw or power for these battery operated IoT devices. So by keeping those network connections to a minimum, only connecting to a network, sending that packet through when there is an anomaly, find a failure with the asset, you're not only saving on the cost of connectivity, cloud cost, but also the battery consumption and battery life for that IoT device as well. I'll dive into the technology behind this in subsequent slides. Looking at how we do this, right? So again, Microai is our core product at OneTech, and really two phases, right? So again, we build the model directly there in that embedded environment, in the embedded environment. And why we think this is the best approach for IoT deployments. Let's take a smart water meter use case. Let's say Gary and I are neighbors, right? And we both have smart water meters on our house, and the typical approach to deploy, AI on those devices would be to take historical data for a neighborhood water consumption up into a cloud, form the model, and push that model down to all the smart water meters in our neighborhood. Let's say that Gary has a pool, lavish landscape, lots of people in the house showering and whatnot, and I may be that neighbor that just does not water. So that cloud-trained AI model would say, Gary, you're using way too much water. Chris, you're not using enough water at all. Versus our approach of training in that local environment, we get a much more accurate and precise understanding of what true norm is for those individual households. Very similar with, let's say, a robotic arm, which we'll look at a use case here shortly. You could have the exact same make and model of machine, in this case a robotic arm, but they're performing very different tasks, right? One could be have a MIG welder tool attached to it, and the other could have a material handler in a packaging facility. So just because it's the exact same machine, it's going to have very different behavior. So by training directly there in that local environment, again, we understand what true norm is for that asset. So first step, train the model, pull in the various data points for that asset, form that model there in that local environment. Once that model is trained, switch over to run inferencing and really detect those anomalies, detect those signs of failure. What we do, it's a multivariant model, right? So basically we form a correlation between how those data points are moving in correlation with one another. So think of a electric motor. We may be looking at RPMs, temperature, vibration. As RPMs go up, we're going to expect the vibration and temperature to go up as well, but within a given range, right? So as RPMs go up, we'll have a upper and lower threshold one of those data points that we're monitoring, and if there is if actual exceeds the upper or lower threshold, that's where we can trigger action. If there is a deviation, and this is kind of getting into the weeds of things, but we really allow the users of our tools to go in and fine-tune for their specific use case. So you don't want too many false positives, you don't want too many false negatives, right? And so we give various tools for the users to go in and make those fine-tune adjustments. Think of tuning a carburetor. You may want to run a little rich or a little lean for your given use case. On the right-hand side of the screen here, each one of these columns represents a data channel coming into the AI engine. Yellow block means everything's within those upper and lower thresholds. A red block would mean that individual data point has exceeded. And you can set a specific threshold on when you want to trigger various events. So let's say there's a handful of abnormal patterns going on. You may want to simply just log that as a watch alert or a notification, and then run further analytics on this. Is there any particular frequency or commonality of when this is occurring? The X number of hours after service, is it during a particular weather event? Or if there is a more severe deviation, as we see here, a couple rows of a lot of abnormal data points, we may trigger a automated work order, create a dispatch for someone to actually go inspect that particular machine. There's a handful of outputs that Microai provides by default, and one of those is predicted days to next maintenance. There is a very complex formula that goes behind this, but in simple terms, we look at what the OEM recommends as a standard maintenance for that machine. So that's kind of your baseline. And depending on the volatility of that data that's coming from the machine, we may pull that closer to today, or we may push that further out from the day that maintenance is supposed to be performed. So this really jumps into that predictive maintenance side of the house for extending how long an asset can run without suffering any sort of negative repercussions. Diving into the actual AI itself. So as I mentioned earlier, two main phases for Microai. First, building that model. So raw data comes in, run feature engineering, What I mean by that is you can tune or select specific weight to be given to individual data inputs that are coming in, just to have more emphasis on those particular data channels. Those feed into the AI engine. You can configure how long you want that model to be trained, and the training of the model really depends on what a normal cycle looks like for that asset. So we work a lot with manufacturers, and these machines can have cycle times of 7 seconds. Think of a robot that's performing its task every 7 seconds. Within a couple of minutes, we have a perfectly fine model that's trained. Complete opposite end of that spectrum, we work with a water treatment facility that has backwash pumps that turn on once every 24 hours for 7 minutes. And so in that use case, we had to train the model over multiple days. So the model knew that it was completely normal for this machine to sit dormant for 23 hours and 53 minutes a day. Once that model's trained, then we switch over to start running that inferencing. So raw data comes in, passes through the feature engineering module, gets processed through the AI engine, and the output is generated. So as mentioned earlier, there's an upper and lower bound that is output for each individual data point that's coming through. We also form a health score, heavily, that's heavily produced by the volatility of the data, along with those days to next maintenance for the individual machines. So let's jump over to a quick video here. Kind of see this in motion. Here, this is our lab. In Dallas, we have it's a Dobot, and on that we have an ST Micro, ST Wind sensor. So we just click the button to start the training mode for this robot. So orange blinking light here means that it's in training. So we let that robot go through a handful of normal cycles, form that model. Then it switches over to a green light saying the model's formed, and then we're simply looking at gyroscopic data, accelerometer, temperature of those servos, handful of different data points. And so as it goes through its cycle, we'll simply start we'll start implementing some abnormal behavior to the machine. So simply a collision, right? We're reducing the health score of that device. We're triggering a notification, all based on those accelerometer data in this instance going out of bounds. Very similar use case with a stoppage of the robot, right? So it's not forming its normal path. Again, in the dashboard, we are seeing those data points going out of bounds, which triggers various events to occur. Before we dive into this, so I've been talking a lot about physical sensor values. Instead of looking at the pressure and current and voltage and what have you, we can take the actual device that we're living on and look at, let's say, CPU usage, memory usage, data packet size, frequency, and form a behavioral profile of that connected device. And why we do so is really on the security side of the house. So zero-day attacks, right? Something that we've all been privy to here recently. Whenever that malicious intent is occurring, whenever that hacker goes in and places that malicious code, especially with IoT devices, they have a very common, they replicate their behavior in a very tight manner, right? It wakes up once an hour, sends an 8 KB packet, and goes back to sleep. Whenever that hacker gains access to the device, there's going to be some sort of spike in probably memory or CPU usage. And that action of that particular data point spike, we can call an AT command to have that device reboot to reset. We could have it cut network traffic to that device. So it's a very similar approach for security as we have on the actual physical predictive maintenance side of the house. So with this, we're actually sending a brute force attack to the robotic controller, measuring those various data points on the robotic controller. So this is the mobile application that you see in the top left of the screen. And in the dashboard, the attack is run. We will see those spikes in the various data points. Okay, so let's dive into some of the technical specs of this, how it really works. So we work with Renesys on their RA platform, RA6, let's say M3, so work a lot with ARM Cortex M series, so M0s, M3s, M4s. Work with ST Micro. Here on the screen, you see the ST Win. We like that board because it's relatively inexpensive, and there is a lot of sensors in a very, very small form factor. So accelerometers, gyroscopic sensors, acoustic, so we're looking at ultrasound, acoustic emission, temperature, humidity, probably leaving a few out. ESP32, very, very easy and very inexpensive platform. You can pick these up for a couple bucks. And of course, Raspberry Pi. That's more on the A series of ARM. So you can see here, we are very lightweight on these various embedded environments. So we're talking about the entire Microai engine is 4 kb. So very, very lightweight. The model size really depends on how long you're training that model, saving some of that data in the model, and of course depends on the amount of data channels coming in, but on average we're looking at about 10 kb. So overall 15 kb space to run Microai in that embedded environment. So most commonly in these MCU environments, we're looking at a C library. We also have Python, Golang, Java, many different flavors, if you will, of Microai. There's some other tech specs here, but I think that's the high points or key points there. So how this works, starting with the sensor data, again, you may have a device that simply has temperature and humidity. Someone else may have a device, an IoT device that has 30 different data channels. Ultimately, Microai is agnostic to what those data channels are that are feeding into the environment. So first step is to select those data channels and bring it into the data fusion layer, where we aggregate the data. You can run pre-processing there, clean out some of the noise of the data. And then next, we would train that model. So set how long you want to train the model for. Again, configurable from 200 seconds to multiple weeks if need be. From there, start running inferencing and producing those outputs. Those outputs can stay local in that, that local environment. So it could be a command directly to a robotic controller to have it adjust its action. It could go to an existing IT tool for further analysis or data visualization. Along with that, we tie in system data really for context to the model. So let's think of a AI on a household appliance. Let's say we're running this on a dishwasher, right? We can train in a normal dishwashing mode. And once that model's trained, everything's looking fine. And then I may run a pots and pans surge mode. And as soon as I switch over to that pots and pans surge mode, that controller is now running a different job ID. And Microai would say, whoa, something is certainly going on. Something is different here. So by tying into that controller, we would see that new job ID. And if it is a new job ID that does not have a model form, we can automatically trigger for a new model to be formed for that specific job ID. Very similar in a manufacturing facility, right? This week we may be running Yukons, next week we may be running Escalades. So those different styles of products that are being run, we would have those separate job IDs come through and different models trained.
Question: Is your Microai, is that application specific? You have to, or is it just a standard code You're independent of that.
Yeah, independent of the application. So we have SDKs for various environments where a user can take that SDK and configure for their specific use case and application.
Can you hide that message at the very bottom on your screen?
Certainly.
Thank you.
All right, so diving a little deeper into this, again, far left-hand side, raw data coming into, in this case, a Renesas RA6 32-bit microcontroller. That's where Microai is living, forms model. Here's a better look at those upper and lower thresholds that are formed, right? And so as that actual data point exceeds, the action can be triggered, can go all the way to our platform. So OneTech has a platform that exists, but again, can also integrate to other existing tools. Really creating an end-to-end data pipeline here, right? So the embedded AI, which I've been talking a lot about, connectivity, right? So of course, we work with the 3GPP, LoRa, Bluetooth, Wi-Fi, Zigbee. We're agnostic to how that data is moving. With inside the platform, we allow the users to go in and configure that connectivity management. Also, VODA as part of it as well. So if those devices need to be updated, or if there's an update to Microai, we can push that down to those devices as well. Cloud. So I know I've kind of been talking about there is no need for a cloud if you use Microai. Those notifications and events can certainly be sent up for further analysis, or let's say you're a global organization and you want to have a single pane of glass to see how your equipment is running. You can certainly have that shipped up into a cloud to see that data, but you're not seeing all of the raw data. You're seeing the processed information, really those key insights. Along with that, we also have industry-specific dashboards and workflows really stitched together, again, that end-to-end data pipeline for many different industries. Now we'll look at some of those industries that we do work with. Three main buckets. So silicon hardware manufacturers, right? Creating differentiated offerings, embedding this AI engine directly into that hardware architecture. Second bucket is with smart device and smart equipment manufacturers. So equipment is going through a craze of lots of instrumentation, lots of sensor data being generated by these devices and equipment, but not necessarily processing any of that sensor data locally. So working with a lot of different manufacturers in the space. Then, of course, the asset owners. They're the ones truly feeling the business challenges and whatnot with lots of data being generated, lots of data being sent to a cloud, sitting in a cloud, and they don't know what to do with the data. So they're hiring data scientists. Their data scientists are looking at the information that they have, struggling to figure out what to do with it. Overall, the asset owners want less unexpected downtime, more output from their assets out in the field. So these deployments that we have at OneTech really fall into predictive maintenance. So detecting those abnormal patterns, looking at the health score, looking at those upper and lower bounds to understand if it's behaving in the way that it should. Next is operational excellence. So really think of the performance and behavior of that machine. The machine may be designed to run a cycle every 15 seconds, but it starts degrading and ends up running a cycle every 18 seconds, 20 seconds. And unless you're out there with a stopwatch, that may go unnoticed. But over the course of a single shift, 8 hours, in a manufacturing line, those 3 seconds may result into an additional 30, 40 units that you did not produce, right? So that certainly hits the bottom line. And as mentioned earlier, security, keeping these endpoints protected. So work with a lot of different industries, primarily in the industrial space. So manufacturing, I'll go into detail specifically for manufacturing deployments. Talked about the utilities, so smart water meters, automotive, right? So connected cars can and are generating a lot of data, gigabytes of data. Sent off that car through the TCU up into a cloud. Look at driver behavior, the performance of safety systems, the ECU. If that data does not need to leave the car, if all the raw data does not need to leave the car, process it there locally, and again, only send down those key alerts and notifications that do need to be viewed and acted upon. Telco, looking at the appliances in the, let's say, various base stations, ensuring that they're performing and behaving as they should, all the way to oil and gas, right? So midstream deployments, looking at compressors for pipelines, ensuring that those compressors are behaving and performing as they should, detecting those signs of failure prior to any unexpected downtime occurring. Yes, sir.
Excuse me, your area of medical devices, are you going after the manufacturers or the end users, such as a hospital or medical?
Yeah, so typically the OEMs, the manufacturers of those devices, that's who we're working with. The hospitals and clinics are we're engaged with some, but I would say that the majority of the deployments are with the OEMs.
Why not go after the actual end users? They have the manufacturer of a medical device has a certain amount of liability, but it's much greater liability under HIPAA. The Healthcare Act, patient records. If I'm running a hospital, I'm the CFO or CEO of a hospital. I've got a much greater liability than the manufacturer of that device. If I just happened earlier this week, for example, with CNA Insurance, they got hacked and paid a $10 million ransom. Why not go after the end user?
Absolutely. No, very valid point. Very valid point, and certainly something to dive into. I'll find you after. We'll dive into it. Yeah.
Y'all are obviously generating software.
Yes, sir.
And you listed some MCUs with a lot of sensors on them.
Yes, sir.
Do you typically put your software in the designer's hardware, or do you put in a sensor board, put your software with that, or how do you work that?
Yeah, certainly. So I should have stated that at the beginning. We're a software-only organization. Work very closely with hardware manufacturers, all the way down to those chipset manufacturers. So we are really embedding directly into that. Well, depends on the hardware, but it's directly into the MCU. For, let's say, initial deployments, EVKs, evaluation kits, right? Looking on those boards and allowing really configurable environments for the users to go in and modify the data inputs, at various IO. So looking directly on that board itself.
Okay.
Yes, sir.
I know Intel's saying they have embedded AI in their chips. Are they doing similar things that you're doing?
So no one that we have found, and I talked with global research communities and whatnot, and they've backed this up. No one is training their model on an MCU. So Intel can process and run their model on that embedded environment, but that model was originally trained on a server outside system, cloud, laptop, what have you. And then they're taking that model and embedding it there into the chip, but they're not training that model in that embedded environment.
Okay.
Yes, sir.
So for establishing data channels, do you find that you have to add sensors to, some of the manufacturing arms and things like that? I mean, obviously, chips have the data channels built into it. Other manufacturing devices may need to be enhanced to provide the data channels. Do you also recommend that or
Certainly. And there is a automotive manufacturing use case that I'll dive into that speaks to the embedded sensors that were already in existence, right? Already had the intelligence, but we needed to pack the robot. We didn't know exactly when it was having an issue. We knew it was during a cycle, but did not know where the robot was where this issue continued happening. So I'll speak to kind of adding those over-the-top sensors as well. But to answer your question directly, yes.
Chris, is the majority of your business with the smart device manufacturer, or is it with the asset owner?
Yeah, so early days, primarily with the asset owners, and now we're really transitioning to working with those device and chip manufacturers.
And is it fair to say that what you've done is you've taken the equivalent of TensorFlow or one of these other pieces for machine learning and embedded it and packaged it to put it into an MCU?
In its simple form, yes, certainly.
So I had a question regarding that. So obviously you're writing a small amount of code to extend back into some type of monitoring piece of software.
The monitoring, the processing, everything is within that small piece of code.
But in regards to pulling that out and doing the dashboarding, you obviously had some other software.
Certainly.
And so my questions were around that. So I saw how you had the SDK kit for the actual devices, but similarly on the back end, how are there APIs into your monitoring platform, or what are your integration points on the back side of that that you already have today?
Absolutely. So the very good question. There's a lot there.
Yes.
So Microai really has two different data channels coming out of it: a synchronous feed and an asynchronous feed.
Okay.
So the synchronous feed is basically a heartbeat. If you want to get data out of that device, just know the device is alive. Let's say once an hour, once a day, once a month, what have you. And you can say, give me the maximum and minimum, maybe mean, mode, what have you, data coming out of this device on a certain frequency. Then the asynchronous feed is when there is an abnormal event, right? Sign of failure. That would automatically go out when that's detected. Those two data channels can be pointed wherever they need to go, right? So whether it's our platform or existing tools, it can be pointed there. Our platform is completely built on APIs, right?
Okay.
So
you've got JSON streams going back and forth then?
Yes.
Okay.
And it's a massive platform. The same underlying technology that we built out there is deployed for AT&T and dozens of applications. Beyond AT&T, lots of telcos across the globe, big manufacturers. So there's not only just the dashboarding and visualization of the data outputs, but workflows and further analytics, right? So if I'm having issues with devices, is it particular make, model, batch, lot, customer, region, etc. So a lot there.
And we have a question from online. I just want to interrupt here. So from Brian asks, what types of neural networks can you support? And is this for 1D telemetry data? And does it extend to 2D and 3D data?
Yeah, good question. And I need to have my data science team here to answer this in complete detail. So it's not a neural net that's running. It's a multidimensional behavioral analysis. It's proprietary build by us, and in very simple form, we form a behavior profile on that asset, right? Okay. Watching it, really observing as a child learns, right? That we're watching the surroundings, understand what normal is, and put that as its nominal baseline. Brian, feel free to chat with Brad after this, and we can get your contact information. And if you want to go in more detail, I can certainly get you in touch with people at OneTech, much smarter than I.
How big jumps the field? Do you have to have pretty simple, or is the payload pretty heavy? What do you all do?
So if we're updating have a enhancement or what have you to a model, or if you want to share a model from one device to another. So we have inside this platform that I was just speaking about, we have a FODA firmware over there path to send those updates to the devices that are out in the field. Yeah. Any other questions? Good deal. Keep on rocking here. So to that question earlier, so work with tier one automotive manufacturer. This particular line is located in Kansas, and they're running at about 50% OE, overall equipment effectiveness. Industry standard is about 80–85%, and this low number was really caused by two factors. One, unexpected downtime. If one of these robots went down, the entire line came to a grinding halt. And two was quality of weld. QA was not until the end of this line, which was another 15–16 units could pass through the that particular station, receive the incorrect weld, and all of those units would have to be taken offline, manually reworked, and put back onto the line. So they approached us at One Tech to say, hey, we have a lot of unexpected downtime. How do we fix this? So we went in and tied into existing intelligence, right? Primarily with their PLCs and controllers for these robots and welders. Looked at those embedded sensor values that we're able to tie into. And as mentioned earlier, we brought in over-the-top sensors, a 6-axis inclination sensor to path that robotic head as it performed each cycle. Process that all within inside of the facility, right? So some of our competitors in the space that also bid on this project, we ended up winning against them due to the fact that all of this could be run inside of that local environment. So pulled in the controller data, looking at cycle time tags, fault codes, fault tags coming out of those PLCs, the embedded sensor values, along with that inclination sensor at the top of the tool head, processed there locally, and the output was sent to two different applications. One mobile application running in that intranet, really used by the operators and technicians on the plant floor. So if there was a sign of failure, that tech that's responsible for that zone or station would get the notification, go over, check out what's happening. From there, they could look at and classify that event that was occurring. So they could say, this particular bearing needed to be restored. There was an improper shaft alignment on a particular conveyor motor. On the right-hand side, desktop application, really that's for, plant managers and what have you, for looking at the various facility overall, being able to drill down into particular line, zone, station, asset, and even subcomponents of those various assets. Corporate, then as a phase two, wanted some of that intelligence rolling up to them as well. So a subset of that data is sent for each one of the facilities that we work with into a global view, like enterprise asset management, so they can see their global facilities in that single pane of glass. So after we tied into the various data points and processed there in that local environment over the course of about 90 days, able to get them north of 80% OEE. And this was two main reasons. One was when these robots perform their cycle, once they complete their cycle, they go to a pounce position. Really looks like that robot's going to jump out at you. And if it was not sitting at a true north or a 0 degree, could be off by just a fraction of a degree. Whenever it goes to place that next weld, it would be placed in a slightly incorrect position. Again, QA wouldn't pick that up until another 15–16 units rolled through. So whenever we detected that improper pounce position, we would at first phase would simply send a notification. Now we're tying directly back to that robotic controller for it to reset prior to performing its next cycle. The other issue that we resolved was the weld quality. So this is it's a picture of spot welding, but primarily working with MIG welding. As those MIG welders perform a hit, there's a welding tip at the end that continues to wear. As that welding tip wears, you need to push more current or voltage to that welder to perform the same quality of weld in the same cycle time. So again, whenever we started to detect that that welder tip was starting to degrade, sending a notification, whereas now we're tying back to the Lincoln Auto Access E welder controller to increase the volts by 3 volts every time we do detect that degradation. So it's really automating the looking at the prognostics and automating the fix to those issues that the line was incurring before. Any questions here?
Yeah, so you're talking about adding sensors of various natures, right? And then those become data channels for your simplified drawing you showed. Is that correct?
Correct.
And so you've talked about output times and cycle times, a few minutes, several seconds, a few weeks. Those are things you've mentioned.
Yes, sir.
Right. So I think at one point you said you had a minimum of 200 milliseconds somewhere on one of the slides, and I couldn't tell if that was a feature of the product or just part of an example you were giving.
Right. So there's probably 2 different items there that it could have been. One is the sampling rate or data frequency, right? We have some data channels that are looking at even 50 millisecond data.
1.5?
So 50 millisecond, right? Very, very fast. And I'll come back to that. The other was probably training time, and there was 200 seconds of training time. Basically, that is, I would not train a model for less than 200 seconds. It's a very, very short amount of time.
Yeah. It's a little, okay, so thank you. So now I'm waiting to my real question.
Yes, sir.
So, in a sense, I think what you're saying is someone could take your system, and you raised the issue of an ESP32, okay, and you could put data as you saw fit into a data channel within great constraints. Your system apparently wouldn't really care where that data came from. It's just got rules. You've got multivariate analysis. You've got rules. But if I wanted to take human population movements and distill those down so it looked like GPS data,
You could do so.
your system wouldn't care, would it?
It would not. It would not. Yeah, certainly not.
Fascinating.
Absolutely. So we have an SDK for the SP32, and lots of how-to guides, lots of reference code within inside of that SDK, and we have a team at OneTech that supports our SDK users. So would love to chat with you if you have any interest in that. Back to that 50 millisecond, 200 millisecond sampling rate or frequency of this data. I'm beating a dead horse here, but by processing this data locally, we can get very, very granular in those sampling rates. So think about sending 50 millisecond data to a cloud. It's absurd, right? It's not feasible. By keeping it there local, processing it local, I can increase those or decrease, right? Get much faster sampling rates to just get more granular into how that machine is actually performing. It's valuable for accelerometer data, gyroscopic data. Temperature, not so much. You're not going to have a spike in temperature that you may miss within a few hundred milliseconds, but for those, accelerometer and gyroscopic values, there may be some small details that you would pick up by having those fast sampling rates.
Can you look at like 2-dimensional camera data?
So time series is really right down the fairway for us. Imaging is, we do it. I would not say that you can take the SDK and on your own make it work, but we do have deployments with imaging. It is a really an add-on, if you will. It's becoming asked for. So in these manufacturing facilities that we're working with, the natural progression is to start automating the QA process, right? So we know the machines are now running pretty well. Let's start automating that QA process, which is a lot with imaging, whether it's thermal, right, or looking at the quality of welds, shape of the welds with blue laser data, or imaging itself.
Do you subsample the data before you pass it into your system? Because, I mean, most of the cameras are way more resolution than you would probably want to do.
Yes, there is pre-processing that's done to basically make it into a vector.
And how did you sense the, like on the big welders would get smaller at the tips were decreasing?
Yeah, so at first it was through imaging. And then we started, well, then we understood how many hits it was that actually got to a threshold where we needed to increase that voltage. So now we're simply just counting the amount of cycles and automating that voltage increase after X number of cycles.
Okay.
And that's on a station by station basis, right? And not every single welder is performing the same task, right? One may have a cycle where it's actually performing a weld for 3.5 seconds. Another station may be 18.5 seconds. So it was station by station.
And then online, Brian asked, can this scale to many channel AI applications to monitor hundreds of signals? Assume this is only limited by the processor capability and the latency of your algorithms. What are the typical number of signals you monitor simultaneously? So
Yes.
what's the system engineering cap is, I guess, what we're
Absolutely. Absolutely. So on a ESP32, let's say, roughly around 30 data channels is about the cap.
Okay, I have to ask, following along, 30 data channels at what sampling? Because see, you keep talking about
Yeah.
milliseconds.
Yeah.
My application turns out
Yeah.
I needed to read every 50 microseconds or I messed up. So 30 channels at what data rate?
Yeah, so that'd be about 500 milliseconds.
Yeah.
Yes, sir. Yes, sir.
What's every 500 milliseconds?
Yes, sir. Yeah. And
So that's
it
very
becomes a matter of hardware, right?
right. I was going to say that's very MCU based.
It is, right? So you can scale up to a microprocessor. A Raspberry Pi, for instance, again, very low cost, can run hundreds. So it really depends on the hardware.
So we're a computer vision system integrator, part of our division. We do a bunch of stuff, but that's one of our divisions. So do you all work with system integrators as well, or do you?
We do, and that is Samuel's. That is Samuel's cup of tea there, if you will. Yeah, so we're really looking for those strategic partners. We're growing very rapidly.
Two of them right here.
Yeah, we're growing very, very rapidly, and look for those strategic partners on the SI side.
So, and to Chris's point too, one part of OneTech's mission is truly to be a technology company, enhance our technology, and grow that. And working with companies that want to stay solely in the services section, move the product. Yeah, that's definitely an area that I'm growing. Part of my initiative.
Okay, and then the delivery for you guys, that is the package, or do we do the hardware part? You all still stick because you mentioned you're a software only house, so when we work with the Raspberry Pi or whatever, you'll recommend that, and then is that thing, or does your package entail the whole thing, and then it's something that we work with basically through the SDKs?
Right. So either route works. For the first handful of deployments, we know the sensor and the hardware companies that are reliable, and that our software works well with. Okay, we can certainly recommend, but obviously, if you guys have your go-to hardware partners or what have you, certainly happy to take that route as well.
Is it a per device?
Yeah, good question. So it's typically per asset is how we price. There's a handful of different models that we've seen be beneficial could be an overall license for a particular SKU, right?
Yeah.
So let's say someone's coming out with a smart water bottle, we'll cover that entire SKU for just a single license.
One time.
One time.
Okay.
Good deal. And there we are. So certainly thank you guys. I'm happy to answer any other questions that you all may have.
Yes, Juan, ask online. Yeah, it says you mentioned multivariant stochastic analysis for model creation. Is that the only training algorithm, or do you have others as well? And if so, which ones?
We have others.
Okay.
And I don't want to say the wrong name off the cuff here. So you can either email me here at this email address that's on the page, or visit our website. There's some information there as well. Website's onetech.ai. Those SDKs are also available at the website. And so you can easily see that on the homepage. So feel free to call me, find me on LinkedIn, email me, or visit our website.
Chris, could you spell your last name? It's very small on the screen.
Yeah, Catterton, Catterton. Catterton.
Awesome. Chris, thank you very much. Let's give him a hand, guys. Gary Ramsey is now going to take over for the online question and answer after meeting process. So I'm going to turn it over to him in a moment and let him carry on. If you guys can't come next at one of the times in the future, Gary does this. He does an excellent job of moderating and engaging the people that are online because they can't be here at network like we can. So with that, Gary, go.
Okay, thanks, Ed. Gary Ramsey, and I think we've got everybody promoted here so that they can actually introduce themselves. First of all, can you guys hear me? Brad, since you've
Yes, sir.
Can you hear me?
Yes.
Okay, fantastic. All right, so what I want to do is, we call this kind of the meeting after the meeting. It allows everyone who's online to effectively get that experience that we're let's just say enjoying at this particular point in time here at the Hexa facility. So what I wanted to do is just allow everybody to introduce themselves. Let me know what company that you're working for, and also if you'd like to go ahead and share some information about yourself here in the chat. That way people can get a hold of you in case they're like, oh, there's somebody I want to work with, kind of help build out your ecosystem. So kind of as we know, it's very difficult for any one company to do a full A to Z solution rollout. So it takes a village, as they say, to raise up a project. So what I'd like to try to do is, Brad, why don't you go ahead and just do a quick introduction from your perspective, and that way we can kind of get this thing started off with kind of what you're providing with services and so forth.
Yeah, sure. Yeah, so good morning, everybody. Brad Webb, based out of Houston, Texas. Been with the organization since about July or end of July, August of last year. Prior to that, I was 20 years at AT&T with the device certification organization. So, essentially devices that needed to touch the AT&T network came through my team. And coincidentally, I had hired our parent company, I guess it was back in 2009, which is a company called Plasma Computing. And so if you were on the call in the beginning, Plasma and a publicly traded company out of Tokyo called Sistema had a long-term relationship with each other, conducting a lot of industrial IoT deployments. And so that's kind of where Micro AI was born. And so I think Chris stole a lot of my introduction thunder here, if you will. So you guys pretty much know what we're doing. But nice to meet you guys, and happy to answer any questions that I can.
Yeah, thank you, Brad, for sticking around here for our meeting after the meeting. That, as I said, it allows the gentlemen that are here still left
to get to meet you and the other individuals that are here. So, Mark, since your video's on, I'm going to have you go first. You want to just introduce yourself, what company you're with, and while we're doing this, I'd like to have if you've got any ask of the community or any needs, please let us know what those are. You know, if you're a specific project, you're a hardware guy and you need software or the reverse, whatever, let us know.
Thanks, guys. Appreciate you having me online. I'd normally like to be there. Thank you again, Ed, for everything you do there. Know a lot of you folks in the room and wish I could be there with you. So I'm looking to build something that's based on a no-code, low-code. We used to call it microservices project in the cloud. But I'd like to set something up in Richardson IQ up there. So if you guys are kind of experts in that domain, I'd like to talk to you about that. Thank you. Mark Davini.
Great, thanks, Mark. Yeshwant, you want to go ahead and unmute and introduce yourself?
Hey, Gary. Hey, everyone. My name is Yeshwant Mutami. I'm a technology consultant in the area of AI and IoT and augmented reality and virtual reality. I do have a day job as well, and I lead the standards and ecosystem effort at the optics technology company called Immersion.
Great. Yeshwant, do you have any specific questions? Or Brian, do you want to go ahead and unmute yourself and introduce?
Yep, sure. Brian Carlson, you can hear me fine, hopefully, right?
I hear you great.
Excellent.
Yes,
okay.
thank you.
Is this Ed? I don't know who the speaker is, and I don't see Ed's name. Is Ed on here, or is this Ed, or who's who?
No, Ed's actually in the room. I'm in a little AV closet that's
Got it.
right off the room.
Understand. That's what I thought.
Yep.
It's funny because back in 2014, Ed and I hooked up with about 2 or 3 other people at a breakfast table. We talked about doing this, and it's funny to see over 7 years how this whole kind of community and series developed. So yeah, we all kind of conceptualized doing this back in 2014 was when he was at BlackBerry. I think it was at Intel at the time, but I'm a semiconductor guy. I was in Dallas area for 40 years, I guess, a long time. And I moved to Austin to join NXP Semiconductors. And I lead up the kind of the connected vehicle IoT, basically most of the applications in the automotive. I'm a global marketing director within Austin. So I am responsible for a lot of applications that are AI ML based. So, you know, we just introduced a new processor, went out to volume production just on May 4th, called the S32G2. There's a lot of great stuff out on the site now. Very deep technical stuff's out there too. But I'm looking now, you know, we've been sampling silicon for a couple of years, and we have some major customers in the automotive, but now we went mass market, and there's a lot of applications like industrial that are and IoT applications that are going to use it now. So I'm just out there looking at potential partners and capabilities like this that could be promoted to the market on the processor. So that's why I'm really interested in this topic. Anything related to the ML aspect, because we have some powerful capabilities to take advantage of it.
So Brian, just to clarify, you were one of the original 4 guys at the breakfast. Is that correct?
Yeah, exactly. I think there may have been 5 of us, potentially 4 or 5 of us in the breakfast place in Plano. We were just talking about it, and it just started out in that place, and it got bigger and bigger. Then we got to the big room, and now you guys took it off site. So it was a 7-year journey.
We're reaching out to probably in the neighborhood of about 3,000 people right now.
That's amazing.
With our list. So, you know, be careful on who you have breakfast with, right?
There you go. Yeah.
And we just branched out to create the IoT happy hour now. I don't know if you heard this earlier, but we had 285 people RSVP for the online session portion of that 2 weeks ago. So
yeah, that's amazing.
The invite there went out to about 5,000 people. Well, it's amazing what this is mushroomed into, and as Ed said, we've taken this thing international. We've actually had speakers from various different locations around the world. So that's kind of my goal with this meeting after the meeting is
Yeah.
to allow people who are online
Perfect.
or not necessarily available here in the Dallas-Fort Worth area to show up physically to still enjoy the camaraderie and the whole IoT ecosystem. Because as I keep making a big deal about, it's all about building your ecosystem and getting to know people that you feel and like working with and trust and so forth, and then just going to market together. So I'll just remind everybody, the happy hour on June 3rd will be at the Sonesta Suites, and we'll be giving away a one-night hotel stay. So for those who are in the Dallas-Fort Worth area and are able to show up for that, again, June 3rd, that'd be great. And again, we'll talk about the business side of IoT. So any last questions, Brian?
No, love Sonesta. That's our go-to also for a lot of things we do here. So, hey, maybe we'll do an Austin chapter, and then you guys can call remote sometime.
Absolutely. We'd love to do that. All right, Jay, you want to unmute yourself? Well, it looks like you have. You want to go ahead and introduce yourself?
Okay, thanks everyone. Good morning, everyone. Again, my name is Jay Hegde. I'm one of the co-founders of Orchestra Technology. I think I have met a few of you all while I used to attend these sessions face-to-face, so we hope to do so soon. I think we primarily focus on the telecom vertical. We develop software and services from the mobile devices to the core network. 5G, IoT, edge computing are some of the things that we work with our customers. So we would like to partner with anyone who has services that we can support our customers. Our customers are, T-Mobile, Samsung, Nokia, Ericsson. So if there is something that we can help our customers with, and you have a product, we'll be glad to take it to them. And if you want to take our products to your customers, we're glad to work with you all on that one too. Thank you.
Yeah, thank you. That was actually, I'm sorry, I apologize. I was writing your name down. I'm going to put my contact information down here in the chat, Jay. I'd like to have you reach out if you don't mind. There's a couple of accounts that I think we might be able to work on together. So let me do that here now. And in the meantime, did you have any questions or ask beyond that? Did you like to ask?
I will touch base with you, definitely.
Okay, fantastic. Brad, can you maybe discuss just a little bit on, again, kind of the business side again of the model for licensing? Just kind of how does that work, and kind of maybe just describe your pricing model, if you could, for a minute.
Yeah, so the modeling can go in a multitude of different flavors. We tend to, like we operate here in South Texas, is make it stupid simple. And so when it comes to different organizations, you may have a license-based approach where you've got Model X, and you license the Microai technology to work directly on there. You've got other organizations that do it on a per asset level. You've got some organizations that do it on a per asset level, but at a more monthly cost. If we embed, our AI, ML, the security offering, we've got the capability of adding SIM connectivity. So in the event somebody needs to jump on a cellular network, and then of course our back office infrastructure if needed, visualization, that kind of thing. So it really kind of depends on the use case itself. From a cost perspective, I can tell you, if you were to do everything and everything that I just mentioned, our cloud infrastructure, SIM connectivity, the AI, the ML, the security, you're looking at probably $5 to $6 a month per asset, and it can scale up and down from there, just obviously depending on volume. But yeah, it just really depends on the use case and the vertical that you're in.
We all know that it's kind of a scary situation when you open up your AWS bill and find out what the heck you just got charged for the month before. And it's
Bezos loves that, though.
what was that?
I said Jeff Bezos. He loves those kinds of bills.
Of course, absolutely, and so it's our responsibility and fiducial duty, I guess, is to obviously just not flood the the cloud with all this extra data that could actually cost a ton of money. So I guess my question is, can you maybe just go over some of the ROI that some of your customers are seeing when you're deploying? Not obviously you're seeing an ROI from just the data and the value of the data that you have, but I'm just kind of curious, just from a keeping the traffic off the network perspective. Can you address that?
Yeah, and again, this is a technology, and of course, I'm going to go back to my AT&T days, even before I was in IoT and sales. But before you even broach the fact of AI, and like Chris was mentioning on the call today, your typical AI firm out there has to transmit that 100% of that raw data up to the cloud to be evaluated. So if you take a car manufacturer, I was on the phone with one last week where they are actually transmitting between, on a low end, excuse me, about 25 gig of data up to the high end of about 52 gigs of data a month. So if you can imagine, just from a sheer cellular cost, that's extreme. And then once you get that, let's just, say 50 gigs of data, then you got to have somewhere to put it, right? And so then you pick your poison, AWS, Azure, whichever, and now you've got a dual expenditure. And when I approached that exact question, Gary, that you were just asking, are you interested in saving money on those two costs? And the immediate response back was, Brad, all I got to do is go ask for more cloud storage, and I got it. That's like an expense that I do not have to fight on. And so after you go through and say, well, great, I'm glad you got an organization that supports you there, but man, you could utilize that GL string on another item. And so it became very apparent to these guys that if you could run local on the asset itself, it's a van in this case. What if you could trim that down by 50%? We are in talks with them presently, so we have not gone through a proof of concept yet just to get the true numbers on that particular use case. But even a 50% reduction typically raises eyebrows in a good way. And we feel that we could do it even less, just because that raw data, just to get up to a cloud to tell you, hey, Gary, your truck is running great. What's the point? To get a health check-in every now and again to say everything's good, no problem. But you don't need to send all that, raw data up to the cloud to have those expenditures, tell you so. So in a roundabout way, your return on investment on the car manufacturer assembly line, that manufacturing line that Chris spoke on, that was a multi-million-dollar situation that those guys had in downtime. And so deploying Microai to get ahead of the curve, to then turn around and phase 2 control those robotic arms, to them was a major cost savings. And so anyway, it really depends on, again, the vertical. You look at something like agricultural, they're drilling down into saving gas. That was their big deal. Very big banana farm where we are monitoring the soil at different parts of the facility. And so, having to drive back and forth just to go, get a quick sample, that was a big thing to those guys. So, you look at, savings in different parts of the business, not necessarily just your typical, internet connectivity and that kind of thing. So anyway, long-winded answer, but Hope that helps.
Hey, Brad,
No.
that was good. That was good. And coming from automotive, you're singing the same tune I am. And this is why we're playing where we're playing at the vehicle edge. We're providing new levels of platform processing that weren't in the vehicle before. It's shifting from a microcontroller world to a system on chip world. So we really are transforming the next generation of vehicles that are actually coming to market starting this year. So I totally agree. It's about the edge. It's not only the amount of data, because we show use cases where we can reduce between 75 and 98% the amount of data. There's a lot of techniques. So yeah, definitely what you're doing would be tied in very well to that. It's the transmission cost, as you said. It's the latency. It's all those issues. So having the processing. I would say one other thing is privacy is a huge concern of data. So that's one thing you need to probably integrate into the messaging is the privacy issue, especially in Europe. So you get, I think we're well aligned. I'm going to follow up with you because I think there's some interesting things there. I have to run to another meeting. I'm already 25 minutes late too, but I wanted to at least meet you guys and have the conversation here.
Yeah,
So,
I appreciate the questions, Brian, and yeah, definitely. I sent you a LinkedIn request. Let's
already
connect,
agreed to it. Yeah, we're good.
Okay, great.
We're good. Follow up. Thanks, guys. I appreciate it. Good to meet y'all.
Have a good
Yes,
weekend.
thank you for sticking around. We all appreciate that. Thank you.
No problem. Thanks. All right, we'll see you. Bye-bye.
Okay, thank you. So we had a comment, and maybe you can kind of expand on this a bit, but you kind of freaks people out when you make the bold statement, no need for a cloud if you're using Microai. Can you go ahead and expand on that a little bit?
Yeah, and to be clear, I'm going to answer it in two parts, I'm going to kind of dovetail on what Brian just talked about on privacy, keeping that data local, keeping it private. So that car manufacturer that we've been talking about, they wanted to keep data on-prem within the four walls. Absolutely no data leaves that facility. And so we were able to go in and actually deploy local servers to conduct, the visualization, the workflows, the ticketing, all of that kind of stuff on site. But then again, we have other organizations that don't have anything, and so they still need the capabilities of work orders and all of that kind of visualizations, et cetera. And so for that portion of it, we are in the cloud, but it's not required. And so again, every organization out there and their third grader that's conducting AI today, those guys are dependent on the cloud. They have to get that raw data up to the cloud, let the cloud process and run it through the algorithms, et cetera, to then come back and say, okay, Gary, we've got a situation. Need you to go, look at assembly line 7. And so that's where we aren't required. We're not dependent on that. And so that's a big deal to be able to do the training and everything local on the edge right there at the asset.
So the other thing was asynchronous versus synchronous. And I guess I'm kind of thinking, wow, that's going to give you the capability of potentially putting, say, a private cloud inside your own four walls so that you have that control and you're not concerned about the data getting outside to the free world. So you could potentially have a data stream going to your local cloud for gathering all that data, that heartbeat, so forth and so on. But then you could potentially reach out to one of the big private or one of the big public clouds with the asynchronous stream to report out and effectively say, hey, I need some help, and let people outside the four walls. So do you have an implementation?
You got it. Yeah, you got it. So one thing that is important to note is that we're agnostic on where the outbound data goes. So you're asking a great question. So when it comes to I like to say we're not interested in reinventing the wheel. If you need our cloud, if you need our capabilities, we can be in the cloud, we can be on-prem. Doesn't matter. If you've already got, let's say an organization is running, pick your poison, SAP. If SAP is what everybody's used to logging into, doing work orders and tickets and all of that kind of stuff, great. We'll just pipe Microai over to SAP and, let them develop and do all of their visualizations, whatever it is they need within SAP. So that's one of the big things for us as well as we've integrated into, now SAP, Ignition, of course, like I said, we've got our own. So again, agnostic being the big takeaway there.
Yeah, great. Well, that's kind of the end of my questions, and we are right here at the bottom of the hour. Let me also just reach out one more time. Any last questions, comments, or again, as I said, I like to give you the opportunity to ask of the community here of any requests or needs that you have.
I'm good from this side. Gary, thanks. This has been a great platform. Everything worked great, and appreciate your hard work behind the scenes.
Well, we appreciate the fact that you were able to be online with us and the presentation. Great job. So we're going to go ahead and close it down at this point. Really appreciate everyone hanging out. Keep in mind, again, we've got our IoT happy hour coming up on June 3rd, and I'm still kind of excited about the fact that we're going to get a free whole night. Someone showing up is going to get a free night stay at the Sonesta Suites. So that said, everyone have a great day, great weekend, and appreciate your participation on the meeting after the meeting. Thank you.
Thanks, Gary.
Thanks, everyone. Bye-bye.